In Lorentz transformation, we have seen the position and time represents are nothing but equations. But now, which we are seeing the most important derivation in numericals, that is Lorentz velocity transformations. Means relativistic velocity in addition we are going to learn here. So you are seeing the first frame is S and the next frame is S dash. Okay. In this first frame is S is with respect to the position X, and in the second frame which is in S dash, the event is taking place at the X dash and the particle P is moving with the UX dash. Means with respect to frame S also we are able to find the particle at x dash is moving with the ux dash is here. Okay, and that entity we can able to calculate from the s frame as well. Okay, most of the students in the numericals they are having the doubt that ux dash which is belonging to the velocity in the s dash frame, now how can we find in s? So with respect to s frame also you can able to find in the Lorentz velocity transformations. Let us see. For example, as I said now, the particle p is moving with velocity ux dash with respect to inertial frame s dash basically, but that it itself is moving with the velocity v with respect to stationary frame s as well. Okay, that itself is moving with the stationary frame s. For example, a ball is moving in the train and the ball is moving in the with the frame of train reference as well as the same velocity with respect to the observer who is in the platform. Now you can see that here, how does we measure? What is the velocity of the particles in frame S? The velocity u v which is in that in the S dash frame. Then what is the velocity in the S frame we need to find out, right? So you need to link two equations. How does it? How by linking we are adding the velocities here we need to understand. Let us see. Here x equal to gamma into x dash plus vt dash. Okay, this is the x position. Okay, how does it have changed with respect to x s frame to the s dash, and you are also seeing the time t equal to gamma into t dash plus vx dash by c square, which we found in a previous videos. This is the time t and t dash relation. Now, how does this useful for us to find the relativistic velocity addition? Let us see. I'm considering little differentiation approach here. Ux, okay. What is this ux or ux prime which we are taking? Basically, ux equal to dx by dt we are writing. What is this, sir? Dx by dt? Dx by dt is nothing but which change in the position with respect to time here. Okay, nothing but velocity of a particle in stationary frame s. Velocity of the particle which is moving in the s dash frame. Okay, with respect to s is here. Now, x is a function of time t dash. This x is a function of t dash, which itself is a function of t as well. Okay, so which itself function of t as well. Therefore, I can write here there is a chain rule in normally in the differentiation concepts. If you go higher classes, of course in IB we will not feel chain rule, but in higher concepts, how this chain rule is applicable. Let us say ux equal to d, how this dx by dt I am writing as dx and dt. I multiply dt dash and divided with the dt dash. Okay, so if you cancel you will get the same thing before as. You can see here this equation I have written dx by dt dash by dt by dt dash. Okay, now what is this dx here? The x is nothing but which we have taken the position equation, that is x equal to x dash plus vt dash. Now what I am doing, gamma I am writing here differentiation of x dash plus vt dash by dt dash as it is. The same thing down, time function I have taken. Time function, I said that though the event is happening in the frame s dash, that itself is a function of in stationary reference also with that. So t function I am writing here, gamma into d into t dash plus vx dash by c square. This is just substitution from the t equal to dt dash as it is I have written here. Now what is the change, sir, here? What is this equation? There is a concept of differentiation, I said, right? Now dx dash by dt dash, change in the position with respect to time, change in the x dash in the sense position of a particle with respect to s dash frame of reference by the time itself of s dash frame of reference. So dx by dt dash is as it is I have written here, plus d, here of course gamma gamma get cancelled, d into vt dash by dt dash. Anything the same function cannot be differentiated if the same function is equal to 1, dt dash by dt dash. So we have here. And coming to the down part, gamma into dt dash, okay, again same function is 1 here, plus the coming to this d vx dash by c square, means dx dash by c dt dash. So this is as it is have written. Now this function I can rewrite dx by dt ux, we have seen here dx dash by dt I can write as ux prime plus v, 1 plus v into dx dash by dt dash ux dash I can write, or ux prime by c square I can write. Now this is a important expression. In most of different velocities we will use velocity of the approach or velocity of the source, depends on that case we can use this ux dash plus v by 1 plus v into ux by ux prime by c square. This is also we call it as the velocity of a particle in frame s, okay, knowing ux dash and v. Ux dash, where it happens, it is a velocity of the particle which is happening in the s dash frame, and v is a in the s frame, right? So this is relativistic velocity addition, we say it is. What it is? Relativistic velocity addition means here we cannot add directly the velocity simple way. Thank you.